Hello, CIS30A. In this week, week 3, we are going to cover sets, collections, decks, functions, modules, and file operation. This is part 1 of 3 videos for the lecture. So to start, we will start looking at the week module, which is week 3. Here you will find the objectives of the week. We will go through and work on Python program that contains sets. We will use built-in methods for sets. We will work with collections module and deck. And we also will create custom modules in Python and write functions in Python along with file handling. So for this week, you are to view week 3 notes and videos. We are to complete lab 3. There is an extra credit opportunity where you can participate in a quiz run review game to help you prepare for the quiz. And you can look at last week's assignments, which was for quiz review to prepare as well. And you need to take quiz 1 by the end of the week. Also, we need to look at the project criteria and start planning for our course project. So on the next page, you will find the notes. In the notes, we will cover sets, collection, deck, functions, modules, and file operations. So to start, we will talk about set. And for set, it is an unordered collection of unique items. So that means that we cannot have repetition in items, and it doesn't have to be ordered. So it is an unordered collection of unique items. And sets are mutable unless it's frozen set. So if it's a regular set, we know that it's mutable, meaning that it can change. And in a frozen set, the items are immutable. So in the case when we use frozen set, the items cannot be changed in the container. So when do we use sets? Sets are used for mathematical operations like union, intersections, complement, and difference. And sometimes you would see Venn diagram being incorporated to illustrate sets. It doesn't allow you to slice or use index operations like what we see with strings and lists. The values does not have any keys associated with them as in dictionary. So unlike list, dictionary, or string, we're unable to slice or use index operation. And Python contains 2 types of sets. First is a mutable set, and the second is immutable frozen set. So to start, we'll talk about frozen set. In a frozen set, frozen sets can be used as in dictionary or as elements in other sets, and it is not ordered. So when we write a frozen set, we would start out, this is the form, frozen set, and then you would open the parentheses, and then within that, if you want it to be iterating, we would include a list. If we don't want it to iterate, then we would simply enclose the values. So the example shown below is we would start with a tuple that would contain A, E, I, O, U. These are the characters or the characters inside the tuple. And the tuple, we declared that as vowels. Next, we would start with declaration of the frozen set. So here I have F set is declared as a frozen set, and the frozen set would contain the tuples, the tuple that would have the vowels that we previously declared. Then we can simply print out the content of that frozen set by using the print method. And so this line here, it says the frozen set is, and we simply bring down the name of our frozen set. And also, if we wanted to have it empty, we can print the empty frozen set is, and with the empty you simply just put frozen set, and that would allow us to print out the frozen set. So here you can see the output. Now to illustrate this a little bit better, we would go into Tawny. So this is my program to show frozen set. Here I have A, and A is a frozen set. So we declared A is a frozen set, and in this frozen set we have incorporated a list 1, 2, 3, 4, and we know that it's a list using the square bracket. So here we can use the content of that list within the frozen set as iterate objects or items. The second frozen set I have is B, and B contains, like A, it contains 3, 4, 5, 6. And notice that all the values are unique within that frozen set. Next, I have C is a frozen set, and it contains 5, 6. So here what we want to do is we want to implement methods, built-in methods in Python, to be able to compare the sets, to be able to look at the content of each set and how it's overlapping or it would be separated. So later in the notes, it talks about the methods for sets. And so to start, we can see here on the bottom of page 1, we can use length to return the amount of elements of the set. We can also copy or create a shadow copy of the set. We can look at the difference in the set, so we can compare the items within one set with another set. And also we can look at the intersection. So with the intersection method, we can return the items that's in both set, the first set and the second set. With is disjointed method, we can return true if there are no common items between the set. And the same with we would use is subset, we can return true if the content of the first set is part of the second set. So as you can see, this gives you the description of how each of the method would give you the result. So in our program, to start, we previously declared A, B, and C as frozen set, and they contain various values. First, we wanted to use is disjoint. And so when we do a print, we want to first state the set that we're evaluating, which is A. And we wanted to compare that set with C, which is in the parameter here. So when I run this program, it's going to tell me that the first output is going to be true. As A is 1, 2, 3, 4, is disjointed from C. It does not contain any overlapping elements from A to C. So A has 1, 2, 3, 4, and C has 5, 6. So there is no same element between set A and set C. So therefore it's going to output true. For line 11, the second method I'm using here is subset. Here what we want to do is we are looking at the values between C and B. So we are evaluating C, which contain 5 and 6, and B, which has 3, 4, 5, 6. As you notice, 5 and 6 is repeated in set B. So therefore, we would output true because C contains the same element value as part of set B. So it would output true, as we see here. For the third method that I'm using, it's called Superset. And here, what we want is we want to evaluate frozen set B with frozen set C. Is B a superset of set C? So B contains 3, 4, 5, 6, and set C contains 5 and 6. So C is containing the same element values as set B, which is 3, 4, 5, and 6. So therefore, it would output true. Next, we would look at a method called copy. So here I declare that C is a copy of A, and I want to pronounce C. So as we recall, A is 1, 2, 3, and 4. So when we print out C, as it is a copy of 1, 2, 3, and 4, we would see that it is a frozen set, and within it, it includes the curly bracket to indicate 1, 2, 3, and 4. So it create a copy, and it would say that it is a copy of a set with the curly brace. Next, we would use union. And here we wanted to join two sets together. We want to combine these sets, set A and set B. So in set A, I have 1, 2, 3, and 4. And in set B, I have 3, 4, 5, and 6. So when we use a union and we print it, we would have 1, 2, 3, and 4. And then it's going to also include 5 and 6. Notice that the value 3 and 4 is only going to show up once, as the set needs to be unique. So it doesn't have a repetition in the set. We will not have 2 of the number 3 and 2 of the number 4. So it simply gives us each unique values as combined between set A and set B. Next, we're going to look at the difference method. So here we wanted to look at the different values between set A and set B. As we recall, set A has 1, 2, 3, and 4, and set B has 3, 4, 5, and 6. So what we have is we would have set A has the difference between set A and set B is the 1 and the 2. So that would be disclosed here when it's displaying for the frozen set. That will be different. And I didn't cover the intersection, so when we use the intersection method, we would look at what is intersected between A and B, the common values that would be A and B. So that would be 3 and 4 as it is repeated in A and also in B. As they are the same, so those are going to be the same values between the two sets. That will be the intersection. The difference would be the values that doesn't show up in one set compared to the other. So as we see that A has 1 and 2 and B doesn't, so it would show 1 and 2 as the output. Why doesn't it show 5 and 6? Because the way that we write the script, we would have A dot difference to B. So it's going to compare A to B, where it's going to see 1, 2 appears in A and not in B. So here is the output for the difference, 1, 2. Next, we are going to look at symmetric difference. Now, symmetric difference, it's going to look at the different value between set A, which is 1, 2, and also the difference between set B to A, that will be 5 and 6. So in symmetric difference, unlike difference, that it's comparing both sets and it's going to look at the values that is different from each of the sets and include them. So in this output, we would have 1, 2, and 5, 6. Compared to only using difference, whichever set that you would use before the difference method, that's going to be evaluated. So it's only going to look at the difference value in that particular set. And that would show you how to use a frozen set with the built-in method for Python. This same example, you can find this on page 2 of the notes. And so you can check it out and you can run it if you like. And notice that the built-in methods and the set information will come up on your final exam. So make sure you look it over. Next, we're going to talk about mutable set methods. So earlier we talked about frozen sets where things doesn't change. We simply just use it to print out the values. Where mutable sets, we are able to update it, change it. So in the mutable sets method, unlike a mutable set method, this one we can have methods like we can add an item to our set, we can clear our set, we can also update, use difference update to remove an item from the set. And so that is also in another set. We can remove a specific item from the set. We can remove an item that do not appear in the intersection between the two sets. We can use pop method to remove the arbitrary item from the set. And we can also use remove. And so here lists different methods that you can use with mutable sets, meaning that we can change that set. So the difference between this and the frozen set in that we would declare the set and we would initialize the items for the set, but in closing the set we would use the curly bracket. So with that, when we print, we're able to access the value, but also with the mutable set, we're able to change them. So to bring this to the example, I'm going to show you the mutable sets example here. So I start out with vowels as the decoration of my mutable set name, and I would have the curly bracket to indicate that it is a mutable set. I start out with A, the letter A, and the letter E. And I enclose that in the single quotation mark showing that it's string. So to start, we simply print out the vowels in that set. And in the next one, so simply it's going to output A and E within that set. And it shows us that it is a set with the curly bracket. Then on line 6, I use the add method to add O to the existing set vowels. So here next we would print it. So on the next output you would see here that it shows me O is then added to the set. So after AE it added the O. And next I had used the add method to add A, and I reprint the set with the A added, but notice that it's still going to give me my set's AEO as A already existed in the set, so it simply would not update that any further. It would keep it as AEO because the second A that we add is not unique, so it doesn't update the set since we last left it. Then next, we have declared a tuple called tup, and inside the tuple, we have initialized I and U. And we know it's a tuple because we simply use parentheses. Then we can use the add method to add the tuple to our val set. So next, when we print, we would see that the tuple is added inside our set that originally had AEO. Now we added the tuple, so it drops in I and U, and it shows that it is tuple that's added, showing the parentheses here. So on the next one, again, we would add the same tuple, and it would give us the same output as the previous because as the tuple is not unique, I and U already existed in the last, since we last added. Then we added it again, it's not unique, so it keeps it the same as the output. And next, we would have another set called numbers. We would have 1, 2, 3, and 4 in the set numbers. What we're doing next is we are going to create a copy of numbers and store that copy in new numbers. So with that, we would then add 5 to new number set. So first we have a numbers set which contains 1, 2, 3, and 4. Then we create a copy of the number set and store that in new numbers. Then we would add a 5 to new number set. Next, we would print it. So as we show, we have numbers as 1, 2, 3, and 4. After we added the 5, we printed new numbers. That's 1, 2, 3, 4, and 5. And then again, we also declare another set called A. And inside set A, we have A, B, C, and D. We have a second set called B, and in B we have C, F, and G. So to evaluate and look at the difference between A to B, we would evaluate the items that exist in A and not in B. So what we have is we have A, B, D, because A exists in A and not in B. B exists in set A and not in set B. And D exists in set A and not in set B. It omitted the C because C appears in both sets. So when we use a difference here, we're evaluating set A compared to set B. And we're only looking at the items that exist in set A and not in set B. Then we go in reverse. We would do a print B difference A. So the difference method here is used to evaluate set B to set A, meaning that we would look at the items that exist in set B and not in set A. So we would see that we would have the F, which exists in B and not in set A, and the G exists in set B and not in set A. So therefore it would output G and F. You can visit page 3 and 4 of your notes to look at the example. You can test out the program. As you see, I put it all in one program here, and I run it to evaluate how the program would output. Again, you would likely see set questions and methods on the final exam and quiz. So next, I'm going to talk about collections. And this is a very brief section on collections. It only talks about using Deque with collections. So in Python, there's a module called collections, and that allows us to use alternative for the data types for high performance, especially when we want to incorporate a larger container and to be able to use function for the creation of the name tuples. So name tuple will be created as a tuple subclass given a specific field. And in this part, what we can do is we can use it to create Deques, which provides a list for fast appending and pop on either end. So unlike lists and other container, Deques allows you to access both ends of the container to add elements to it and also to remove elements from it, from the front and the back of the container. So now here it provides a little bit more information about how collections can be used with dictionary, with chain map, order dict, user dict, and user list and string that allows you to have access to different data types using the collection modules. So in a Deque, which is shortened for double-ended queue, and that allows you to access or append items to the front and the back of the container, and it's generally thread safe and memory efficient. So Deque is used for efficiency, and it is a mutable type in that it uses most of the list operations. You can use index with it. You can also assign index to the item for the Deque, but you cannot slice it as you would not have one direction for slicing. Now, the main advantage of using a Deque is that it gives you faster response when you try to insert an item from the start, or it is at the start of the list. Now, it's not always faster to insert an items at the end of the Deque, but if you try to insert it at the beginning of the Deque, that would be giving you more efficiency. So here is an example of how you would write a Deque. And with this example, notice that we would import collections, and this is the built-in modules that you can use from Python. And from here, what we can do is we can start with declaring our Deque, and this is called double-ended. And since we're using the module, we would then bring it down here and we would implement the Deque method. And with the Deque method, we can append or add items to our Deque. And in this, what we're doing is we're adding a list to our Deque, and that list contained Mon, Tues, Wed for Monday, Tuesday, and Wednesday. Then we would print it. Now, if we wanted to add to the right of the deck, we would then do an append, and that would allow us to add Thursday after the Wednesday, and then we would print it. So next, if we wanted to append left, we would then bring down the deck name, which is double-ended. We would use the dot operator. Then we would do an append left, and we would put in Sunday. So that would drop Sunday before Monday. So unlike append, if you're using append left, that allows you to append the element to the beginning of that list or that deck. Then we print it. Now, to remove, if we need to remove from the right, we would simply use a pop method to remove one of the items from the right hand side. If we need to remove from the left, we would do a pop left method following our deck name and the dot operator. And then lastly, if we want to use the reverse method, we can reverse the items in the deck and then print it. So next I'm going to show this and see the output in Tawny. So as we talked about for each of the section here and each of the method that's being implemented, so from the top we display our deck, Mon, Tues, and Weds. So we have Monday, Tuesday, and Wednesday. Then we added to the right, so we did an append, we added Thursday. Then we did an append left, we added Sunday. So it dropped it to the front. And then we did a pop to remove from the right. So if you simply use pop, then it's going to remove from the right. So that means that it got rid of Thursday. That's gone. So now it just ends after Wednesday. Then when we removed from the left, we did a pop left. It got rid of Sunday. So we're back to Monday, Tuesday, and Wednesday. Then lastly, we did a reverse. So we simply have the output Wednesday, Tuesday, Monday. So it reverses the item. The last item become the first, and so forth. So now we have Wednesday, Tuesday, and Monday. So as you can see, this is the deck with the use of built-in method for Python, and these methods you would often see being used for containers. And in the case of the deck, we can access both sides, the front and the back of the container using the built-in method. This concludes part 1 of week 3 lecture, which we cover sets, frozen sets, and mutable sets, and along with collections module and deck using the built-in method in Python. Please watch part 2 video for functions and the future sections relating to modules and file handling.